Hi everyone. In this video, we will look into Splay trees. We will first look into the basics of Splay operations that we need to understand before we move to search, insert, and delete operations on Splay trees. So let's start. Splay trees are designed for efficient access of the elements. The concept is that whenever an element is accessed, it should move to the root so that when we need to access the same item again, the access time or cost is reduced. One thing we need to note now is that even a simple find operation changes the tree. To perform splay operation, we either do left rotation or right rotation at a time. Right rotations are called zig operations and the left rotations are called zag operations. So whenever we have two right rotations, it is called zig-zag operations, and when there are two left rotations, then we call them zag-zag operations. And in the cases when there is a right rotation followed by a left rotation or a left rotation followed by a right rotation, we call those operations as zag-zig or zigzag operations. So now we take a deeper look into how we perform this playing. There are few cases that we need to remember. We will start looking from the case where the element we want to display has both its parent and its grandparent on the tree. So in this case, whenever, let's say we want to, the item we want to display is element X. So if X has both its parent and grandparent, then there are few cases that we need to cover under those. So the first case is if X is the left child of its parent and the parent of X is also the left child of its parent. So if X is the left child of its parent and also its parent is the left child of X's grandparent, in this case, then we need to perform these two operations sequentially. So let's see one example. This is the case A. So here we want to perform display operation on this node with item 30. So this one is X and we have X's parent and grandparent both on the tree, and also the X's parent is the left child of X's grandparent and also X is the left child of its parent. So this case A is fulfilled. So we need to perform these two operations. So first we perform a right rotation on X's grandparent. So X's grandparent is this node with 50. So when we perform the right rotation, what we do is we pull this 50 down this way on the right side, and in right rotation on one node, its left child becomes its parent now after the right rotation. So after this, it looks like this, where 40 it moves up and 50 it moves down this way. So 40 becomes its parent and 50 is the right child of 40 now, and 30 is the left child of 40 as it was before. There is also something else that we need to note here. Let's say 40 had already had a right child here. Let's say it was 42 over here. So after the right rotation, what happens is when we perform right rotation on this node, we need to make sure that it becomes the right child of its left child. So 50 has to be the right child of 40 anyhow. So the already existing right child of 40, say 42 in this case, should now become the left child of 50. So if there was a right child here 42, then it should move to the left of 50. We will look this into deeper when we actually perform the find, insert and delete operations on split trees later. Mm, and so we only perform the first step. Now in the second step, we perform right rotation on axis parent now. So similarly, after we perform the right rotation, its left child should become its parent. So here 30 becomes its parent, 40 moves down here, and its right child remains as it is. So after we performed display operation on a node with item 30, it became a root. So we already saw the first case. Now there is the second case where both X and its parent are the right child. So in this case, we need to perform these two operations sequentially. Actually, the operations are similar, just the direction of rotation is different. So when both are right children, then it should be left rotation followed by left rotation. And the first rotation is always on grandparent when both are either left or right. So here, since both are right, first operation should be on grandparent. So here we want to perform display operation on 50. 40 is its parent and 30 is its grandparent. So first what we do is left rotation on axis grandparent. So after left rotation, this axis parent, this one 40, it becomes the root here, and the grandparent becomes the left child of the root. So in left rotation, the right child of the node on which we are performing the left rotation becomes the parent now. So here 40 was the right child, so 40 became the parent, and 30 becomes the left child of 40 now. And after this left rotation on axis parent, when we perform left rotation on it, this is how it will look like. So here we first performed left rotation on axis grandparent, and after that we perform left rotation on axis parent, and then the display operation is complete. So after it is displayed, 50 became the root, and the tree now looks like this. So these are two cases. The third case is if X is the right child of its parent and its parent is the left child of its grandparent. So this is the case in which X is left and its parent is right child, or X is right child and its parent is left child. So this is a case of zigzag operation. Even when we look into this tree, we can see like zigzag kind of vibe here. So it's not in same direction. So in this case, please remember I have this case in bracket. So the bracket ones are for this case inside the bracket, and I will be explaining about the ones that I have not mentioned in parentheses. So it's similar. So if X is the right child of its parent, so here X is 15, we want to perform display operation on 15. So 15 is the right child of its parent, but we can see its parent is the left child of its grandparent. So in this case, what we need to do is we first perform left rotation on axis parent. Please note that in zigzag cases, we perform the first rotation on axis parent and not on its grandparent like we did in the cases where both were right child or both were left child. So if X is the right child, we perform left rotation on its parent. So when we perform left rotation on X's parent, 10 should go down here and its right child should become the parent. So here after the left rotation on X's parent, it becomes like this. 10 goes down and 15, which is its right child, moves up and becomes its parent. So we perform the first step. The second step is now right rotation on axis grandparent. So now it became like aligned, the cases we looked before. So after this, what we do is right rotation on axis grandparent. We perform right rotation because it is the left child here. We can see here. So after the right rotation, how it looks like is X, it becomes the parent because here it is right rotation, so its left child should become its parent. So 15 becomes the parent, 20 moves down here, becomes its right child, and 10 is its left child as it is already in the tree. So similarly, when there is this case inside the parentheses, we first do the right rotation on axis parent and then left rotation on axis grandparent. So this is how splaying works. So to summarize this video, uh, here I have added one more case that we did not explain in the video, but it's really easy. So in the case if x's parent is the root of the tree, that is x has only parent but no grandparent in the tree, then there will only be one rotation. So we need to check if x is the left child or the right child of the parent. And if x is the left child, then we perform right rotation on its parent. And if x is the right child, then we perform left rotation on its parent. It's easy because there isn't the case of grandparents, so there would not be two rotations, just one. So we don't need to remember the sequence. And this is the case in which we looked at the examples. So to summarize it, if x has both parent and grandparent, then what we need to do is we need to first check if x is the left child or right child of its parent, and if x's parent is the left child or right child of its grandparent. And after checking this, there are few cases, four cases actually. If x is the left child and x's parent is also the left child, then we perform right rotation, first on grandparent and then on x's parent. If x is the right child and x's parent is also the right child, then we perform left rotation, first on x's grandparent and then on x's parent. But here, these are the cases where the direction is different. So if x is the left child but its parent is the right child of its grandparent, then we perform right rotation on x's parent first and then left rotation on x's grandparent. And similarly, if x is the right child of its parent and its parent is the left child of its grandparent, then we perform left rotation on its parent first, followed by right rotation on its grandparent. So this is all about how we perform these play operations. So once we understood this, now we can discuss about how we perform insert, delete, and find operations on split trees. I will discuss about that in the next video. So see you there.